everybody. I wanted to get this one done really quick. This should be a fairly short one because there's not all that much to it, but I still wanted to make this video really quick because I got to teach in 20 minutes. So, fast video. Today is 3B. Oh, snap, I got to change the descriptor. Hold on. All right, good. So in this, we're going to be able to recognize standard form, which is just another way of saying slope-intercept form. You need to be able to recognize point-slope form, general form. You need to be able to recognize a solution in point-slope form, a solution in standard form. You need to be able to understand the advantages of standard form and calculate the slope given 2 points, and calculate the point-slope form given 2 points, which is an exercise we did last video, but there's faster ways to do it. Okay. So of all the different ways to write a specific linear function, there are 3 forms worth talking about. Y is equal to mx plus b. This is the standard form, or slope-intercept form. And we've already talked about it quite a bit. There you go. There it is. There are other ones. Here's another form. Y naught is equal to mx minus x naught. This is called point slope. And so, for example, y minus 5 is equal to 2, x minus 1, and y is equal to, copying them out of my book, y minus 1 is equal to 2, x plus 1. And there's a third form that looks like this, a x plus b, y is equal to c. This is called general form. So, for instance, minus 4x plus 2y is equal to 6, or 12x minus 6y is equal to minus 18. Okay, so before I go on, I want you to note something. I'll leave it to an exercise to you, but if you rearrange this equation, you get this one. If you rearrange this equation, you get this one. If you rearrange this equation, you get this one. If you rearrange this equation, you get this one. All of the equations here are the same linear function. They're all the same. So, in other words, there's different ways you can write the same line, different ways you can describe the same line, and these come up in various circumstances. So before I go on, let's just talk about recognizing a specific form, because you see it sometimes. 3x plus 2y is equal to 17. Or y is equal to 4x minus 1 plus 2. Or y minus 4 is equal to 3x plus 1. Or y is equal to 2x plus 2. Or y is equal to 3x plus 1 minus 7, or y minus 2 is equal to 4x minus 11 plus 2. Okay, so I've written a bunch of equations down here. I want you to go through them and recognize which ones are in slope-intercept form, which ones are in point-slope form, and which ones are in general form. And which ones are none of them, because it's possible to write an equation in none of these forms. These are the useful ones. It's possible to extract information really easily out of these 3 forms. So which one is which? Well, this one is slope-intercept form. And you know it's in slope-intercept form because there's y on the left-hand side, and then on the right-hand side there's a linear polynomial involving x in its expanded form. Okay? So that one is in slope-intercept form. Point-slope form, the way to recognize it is there's a y on this side, and then it goes minus a number, or plus a number. There's nothing multiplying them. It's just them all alone. And then on the right-hand side, it's some number, and then in parentheses, x minus another number. And there's nothing else. Okay. So this one is in point slope form. You know what? The other two aren't in point slope form. So these other ones, well, okay. So what about the general form? This one's in general form. General form is featured with the x and the y variables on one side of the equation. So it's some number times x plus some number times y is equal to a constant. So this is general form. These other ones aren't, they're all linear equations before we go on, but they're not in any point slope form or any standard form. Why isn't this one in general form? Because the x and the y aren't on the same side. Why wouldn't we say that it's in slope-intercept form? You'd say it wasn't in slope-intercept form because, look, there's supposed to be, it's just x alone. There's no room for that. Okay, so that's not slope-intercept form. Why isn't it point slope form? It's not in point slope form because point slope form has nothing added to the back end of here, whereas this is plus 7, it's not in point slope form. This is plus 2, it's not in point slope form. This is a plus 2, not in point slope form. Minus 1, not in slope-intercept form. Okay. So the long and the short of it is, it's possible for us to write a linear equation in one of these three forms or in none of these three forms at all. So these three forms are special in their own ways. They all have advantages and disadvantages. So I want to list through the advantages and disadvantages. You might want to come back on this particular thing in a little while. But good and bad. Okay, so general form. That's this one. Ax plus b. Ax plus by is equal to c. It has advantages and disadvantages. Point slope. It has advantages and disadvantages. Point slope form goes like this. Y minus y0 is equal to mx minus x0. Point slope form is actually my favorite form, but you don't care about that. And then slope-intercept form is the last one. That's the one we spent last time talking about. Sometimes we call it standard form. Slope-intercept. Mostly you'll hear me calling this slope-intercept form. I mean, I have before in this course. I just like calling it slope-intercept form because that's how I learned it. Okay, so the general form, it has advantages in a field called linear algebra, which is about solving sets of equations. So if you're learning linear algebra, your straight lines will all be given in terms of general form. It's a wonderful way to write a line, and it generalizes to higher dimensions. It's a really interesting way. The information in there is super interesting. But it's not very good at a lot of things. It's bad at graphing. It's not even clear how you're going to graph that. It's not very good at telling functions apart. What do I mean by that? I mean, okay, so we got two here. These two are the same. If I solve them for y, I can put both of them in the standard slope-intercept form, and they'll turn into this. They're the same function. But if somebody came up to you on the street and showed you these two expressions, this one and this one, could you say that they were the same? Could you tell if they're different? It's not apparent that they're the same and not apparent that they're different. So it's hard to tell whether a function is different than another one or it's the same. So that's a bad aspect to it. It's hard to interpret. It's also difficult to spot solutions. Solutions, by the way, are pairs of numbers, like say 1, 5 is a solution. By solution, I mean you plug 1 in for the x and 5 into the y, and you get 5 is equal to 5. I'll talk more about that in a little bit. But the idea here is you can't look at an expression like this and spot solutions off the top of your head. It just doesn't work. I don't know. Oh, snap. What about point slope form? Point slope form has its advantages as well. Point slope form, it's good for graphing. It's also good for spotting solutions. We'll get onto that in a second. It's bad, though, for linear algebra. And it's bad for telling functions apart. So, for instance, this expression and this expression are both the same function. How can you tell? They look totally different. So, yeah, whatever. So it's hard to tell that they're two different ones. It is really easy to spot solutions. Slope-intercept form is the best form. That's why it's called the standard form. It's the one you're going to be hearing about the most in this course and future courses. It's really good for graphing. It's super easy if somebody gives you a solution for graphing. Oh, you know what point slope form is also good for? Someone gives you 2 points and they ask you to find the equation. Point slope form is super great for that. All right, slope intercept form. Good for graphing, good for spotting solutions. It's the best for telling functions apart. Like we said in the last video, you just compare their coefficients. It's also bad for linear algebra. The long and the short of it is, this is the one that's easiest to start with if you're given the equation. And this one is actually easiest to start with if you're given 2 points and you're asked for the equation. So it depends on whether you're given the data first or the line, or the equation. If you have the equation, then the standard form's the easiest. Okay, what do I mean by spotting solutions? I mean, like, somebody gives you y is equal to 2x plus 3, and they ask you to name one solution. Find one pair, some number for x, some number for y, where if you plug them into this expression, you'll get an equal sign. It's not tricky for this one. This is in slope-intercept form. You just set x equals 0, and then y is equal to that number there. That's the y-intercept. The definition of the y-intercept is it's the value of the function when x is equal to 0. Yeah. So you can just look at it and tell me one solution. Can you tell more than one solution? Nah, it's not that hard to work with, though. You just, x is equal to 1, x is equal to 2. But those are all involved, like, evaluating the function. I mean, can you just look at these numbers and tell me what a solution is? General form, like I said before, minus 4x plus 2y is equal to 6. Like, good luck trying to spot a solution to this. You have to actually do a little math. You go like, I don't know, x is equal to 1 maybe? So then that's 4 times 1 plus 2y is equal to 6. And maybe you solve that equation. And it's like y is equal to, I guess, 5. It takes a while. You can't just spot them on the spot. General form's terrible. Okay. Point slope form. Surprisingly easy. Watch this. Oh no, I wrote it wrong. Here, let me convert to a different, easier to read color too. I'm sorry, I got in the reds. Y minus 4 is equal to 3x minus 2. Alright, here's the solution. X is equal to 2, y is equal to 4. Where'd that come from? Well, to find the solution to point slope, to find a solution to a point slope form of an equation, I just figure out what value of y makes this 0, and I figure out what value x makes that 0. And also, I mean, to put a finer point on it, it's that number and that number. Let's try another example. Y minus 2 is equal to 3x plus 1. Find a solution. Y is equal to 2, x is equal to minus 1. Yeah. It's not rocket science. You just set each side equal to 0, and you're just like, y is equal to 2 makes the left hand 0, x is equal to -1 makes the right hand 0. But this is actually pretty neat. So this comes back to the form of the point-slope form. The form of the point-slope form is written like this, x minus x0. And it's written like that for a reason. M is the slope, so the number out front is the slope. So the slope on this one is 3, okay? And then these two numbers, that number and that number, so in the first case it was this number and this number, and in the second case it's this number, and you have to be careful about that one. But these two values are a solution. X naught, Y naught are a solution. The coordinates of a solution. So you have to be kind of careful with the signs there, but it's not too wild. One thing you need to be careful about is that different expressions might correspond to the same line, even if they're written in point-slope form. That's not the case for slope-intercept form, but it's definitely true for point-slope form. All right, both of these have the same slope, which means they might be the same line, but it's still very possible that they're not. How do we figure out if they're the same? You got to put it in slope-intercept form. Y is equal to 3 times x minus 1 minus 1, so that's 3x minus 3 minus 1, so that's 3x minus 4. And the second one is y is equal to 3x minus 3 plus 5, which is 3x minus 9 plus 5, which is 3x minus 4. They're the same, okay? So just because they look different, just because this point is different, doesn't mean that they're different linear functions. They're the same linear function. To tell the difference between them, or to see if they're the same, you just have to write it out in point-slope form. Okay, oh geez, I'm really running low on time. Okay. The real advantage to point-slope form here is those old questions. If I'm given a find a line through the points, say 2, 1, and 4, 7. Somebody asked me to do this. I showed you a way to do it before that involved a little bit of algebra, and it works pretty well. But point slope is super easy to do because x minus x naught is equal. This is the last time I'm going to do it with like not enough time ahead of me. So what makes this easy is I can just plug these values in, right? So y minus 1 is equal to m x minus 2. I still don't know the value for m, but if you think about it, this value of x and this value of y should be a solution to it, just like in the last cases. So you can plug those in. The value of y is equal to 7 there. The value of x is equal to 4. So this is 6 is equal to m times 2. So 6 over 2 is equal to m. So m is equal to 3. And then I can just plug that back into my original expression. Minus 1 is equal to 3, x minus 2. Ta-da! Point-slope form. It's not too tricky. Okay, now the deal is that it's super easy to solve this question now that I'm given now using point-slope form instead of slope-intercept form is like one fewer steps to do it. But to add to that, there's one quick note. Let's think about how we solved the slope last time. What we did is we said, okay, so you had x1, y1, and x2, y2 were the two coordinates of the points. We plugged one into point slope form. Wait, I messed it up. Oh, rushing is terrible. Okay. Y minus y1 is equal to m x minus x1. And then you plugged in the y2s. y2 minus y1 is equal to m x2 minus x1. And then you solved it. M is equal to y2 minus y1 over x2 minus x1. This is a formula for the slope that always works. And one way to describe it is in terms of, we do it in terms of delta y over delta x, the change in y divided by the change in x. Delta y is the y value of the second point minus the y value of the first point. Delta x is the x value of the second point minus the x value of the first point. And then you just calculate those two numbers and you divide them, and that's what your slope is. So let's try this again. Find a line through 1, 3, and 3, 9. First, I'll calculate the slope because I just want to demonstrate how to do that. First, so delta y, that's 9 minus 3. And then delta x, 9 minus 3. And delta x is your final x coordinate minus your original x coordinate. So this is 6, and this is 2. So your slope is 6 over 2 is equal to 3. And now I just plug these into point slope form. Right? So you go y minus, just choose one. You can use either of them. It gives you the same number each way. Slope times x minus 3. And I'm done. So I gotta go. Also, that's the end of the lesson, so we made it in time in spite of all my bundling. But the long and the short of it is there's different methods to write a straight line. Point slope form is the most obvious way to read it, but slope intercept form, mx plus b. This is the easiest way to read it and interpret it. Like, life is really good if it's written in that form. However, point slope form is really useful if we're trying to build the equation giving the 2 points. All right, that's it. I'll talk to you later.